again. And number 1, we only got 20 questions here. A wiring diagram illustrates 3 wires that are joined together at C215. Now read these chapters. Don't try to dodge that because you're going to miss out if you do. A wiring diagram illustrates 3 wires that are joined together at C215. Technician A says the wires are connected together at connector C215. Technician B says the 3 wires are part of circuit 215. All right. Now, and it says illustrates 3 wires that are joined together, right? Connector C215. When you're going to have a connector here, the connector is going to be illustrated in a schematic like this. Right there, see there? All right, now, if you see a dotted line, that means they're all in the same connector shell. But what they're trying to ask you here is if you see one that's like this, that means they're all joined together right there where they go through that connector. I mean, that is a really, some of these questions, I don't like the way they're worded, but that's what they're talking about. If you saw it this way, all that means is they're in the same connector shell. It doesn't mean that they're hooked together. It just means they're in the same shell. So on that one, if you want to get that one right, put A down there. Okay. Yeah. Which of the following is not used to protect a circuit from too much current flow? Bus bars.
Circuit breaker.
I will tell you what you're going to see sometimes. Listen to this. Watch this, guys. Sometimes you will actually see a circuit requiring a heck of a lot of current to have 2 wires going through it. And they'll be connected to a bus bar and they'll be feeding whatever, but if they're needing 2 wires, they got 2 wires feeding the same thing, and you're saying, why in Sam Hill did they do that? Because they were worried that 1 wire couldn't handle it. So they're basically giving it more current carrying capacity. But number 2 is a B. All right. An operative radiator fan needs to be repaired. Oh, great. They meant to say inoperative. I tried to read it that way, but that ain't how they put it down there. An inoperative radiator fan needs to be repaired. If it's operative, would it need to be repaired? No. I might have called these people better.
Technician, neither.
Well, technician A says a single circuit type wiring diagram would be the simplest diagram to use. Technician B says a component locator will probably be needed to repair this circuit. You're going to have both those guys are right. You got a wiring diagram, a component locator. What's a component locator to? A component locator tells you where the stuff is. I say, well, I looked at my wiring schematic. I know I've got a problem at connector 215, but where does Sam Hill is connector 215? Because I got to find it on the car. Okay, so your component locator, if you look, it'll say component locations, connectors, C215, behind the headlight on the right side, underneath the battery or whatever. It'll tell you where it's at. Okay, that's how that works. Really important you know how to do that. Where is the best place to find the location of a blower relay? Number 4, that's going to be in your component locator. We've all been there, guys. I mean, I have you guys do this kind of stuff all the time. You've done it. Technician A says wiring diagrams give specific circuit information and details. Technician B says wiring diagram will help you find the fault. He's right. Both of those guys are right. Number 6, how are fuses rated? By current capacity. They also are different colors, right? Okay, how many amps does a blue fuse have? 15. How many amps does a red fuse have?
10.
How many amps does a purple fuse have?
5. No.
That will be 2. What about a clear fuse? What about if it's just natural color?
5.
No, that's 25. Now 5 is actually orange, but there's a deeper orange one that's a 40.
Yeah.
That's 40
You
amp.
don't want to get those confused.
There's a real big one that's 150. Yeah.
I thought I went. There's a junction box, by the way, but I thought I was going to show you one they had on. I got one somewhere that's actually got. Oh, here we go. See this junction box right here? See that little? This just came out of a. Who put this little hippopotamus with the?
Hey, I want it.
Please.
Can I have it?
Oh, that's awful.
What is
All right,
that?
this guy is leaking its little styrofoam things out. Okay, now see this right here? That particular orange paint around that one, that means that when you're going to park the car, and it's like a Ford Contour, or I think Mazda 626 may have been that way too, you pull that fuse in order to kill the radio and the lights and the things that would kill a battery if you leave it sitting. That's what they got ignition off draw fuses, right? This is see an orange fuse, a heavy orange fuse. That's a 40 amp fuse. A 30 amp fuse is green. Got that? Okay, so y'all need to mesmerize
What would you use
it.
a 40 amp fuse for?
Well, you're going to use it for something that's really heavy duty, like that circuit coming out of there is feeding, something that
You know what we
that
have
can
relays
handle.
for?
Huh?
You know what they use relays for now?
Well, they do, but I mean, the fuse has got to, the relay's got to be fed with power through a fuse.
Yeah.
And sometimes those little junction boxes go bad. I got another junction box over there that was keeping the tail out from working on a Toyota pickup that we had out here. All right. I mean, they just wouldn't work sometimes. They had power going in, but none going out. Bang, bang, bang. Something would flicker off and on. You replace that, $115. You throw a, whatever. 8. Technician A says a twisted number 7 is where I should have been. Technician A says 2 connectors with the same number are physically the same connector. Is that right? Yeah. He is right. If it's got the same number, it's the same connector. And this is what they're talking about. You may have a component here, and you may have wires coming in, and it'll say C215. I'm going to use that because we've been doing it. And coming out over here, you may say C215. It may look like they're in a different place on that box, but it's the same dadgum connector. They're just drawing it because that's the way it works best on the schematic. They have to do all kinds of stuff on schematics to make them work, to lay them out where they're two-dimensional and all that. I worked with a guy one time that could show you anything you wanted to know on a wiring schematic, but if you went to a three-dimensional car, he'd get confused. You know what I mean?
Same way with like when you're timing something.
I tell you, yeah, exactly. I tell you something else. You can learn what we're talking about in here, and you can get where you understand it. The same guy went to a Ford school, 2-day wiring class at Ford school. He came out there ready to change the world, and he fixed everything they threw at him was electrical for about 2 days, and then he went on vacation, his vacation was coming up. When he came back from vacation, he forgot everything he learned, couldn't fix the darn thing.
That sucks.
He needed to burn it in, okay? And if you don't burn it in, sometimes you're going to hear me ask you to do the same thing more than once, and you're going to be thinking, oh, crap, I've already done this. I'm basically just trying to fix it where you burn it in where you won't forget it. You're rewiring parts of your brain whenever you do that. It's got to be reinforced. Technician A says stranded wire has more resistance than solid wire.
Hold on.
Did you skip number 8?
Skip number 8.
I'm not exactly sure.
I didn't hear number 7.
Oh, you didn't hear number 7?
I think.
I'm sorry.
I heard you explain it. I didn't hear the answer.
Oh, 2 connectors are the same connector. That's basically going to be a C there. And number 8, technician A says twisted/shielded wires carry low current, and repairs to the wire must not increase the resistance of the circuit. Right? That's typically right. Technician B says twisted shielded wire carries high current, and any repairs must not increase. Now they're low current. That'll be like sensor wires.
Yeah,
Anytime you see twisted, that's either going to be
Crank angle sensor.
crank angle sensor, or it's going to go your communication bus or something like that. So that's the way that goes. Number 9, technician A says stranded wire has more. Huh?
Hey, right?
Yeah. Technician A says stranded wire has more resistance than solid wire. Technician B says there's more surface area exposed in a stranded wire due to electron flow. That's B. See, the electrons don't run on the inside of the wire. They run around the outside. Okay, now if you're really wanting to flow a lot of current, are you going to have a solid piece of wire, or are you going to have a solid piece of wire?
What?
If you want to flow a lot of current, are you going to have one big, thick copper piece of wire or a lot of little bitty pieces? There's more area on a lot of little bitty pieces of wire than there is on a big, thick piece of wire.
Right.
Romex wire, like you use in your house, is just a thick piece of 12-gauge wire because it ain't going to carry a lot of current typically. You know what I'm saying? But now but like a battery cable or a welding lead.
Yeah,
You know which vehicles though had the biggest battery cables that you might want to see for years? The ones back in the 1950s when they had 6-volt systems. Those cables were bigger than your thumb. Big old huge cables.
Wow.
Because they needed to have more current flow out of that big 6-volt battery. All right, everything had to be. And furthermore, they made stuff a lot better in a lot of cases back then than they had to. Sometimes they made crappy, but sometimes they made stuff stronger than it needed to be. And when they finally found that balance, they knew just exactly how to do everything. It took a while. Technician A says if a fuse burns out when a switch is turned on, the short circuit is present before the switch. Technician B says if a fuse burns out when a switch is turned on, it's present after the switch. What does before and after mean? Okay, here's your switch, and here's your load, and here's your fuse. Right here. If I close my switch and pop, it blows the fuse, that means that the short circuit's going to be right here, or the load's going to be shorted. One way or another, it's down this way. All right, you got that? So number 10 is going to be B. All right. So if you had a short right here, it would be blowed all the time as soon as you put it in. Yeah. Let's see, number 11. A switch drawn on a wiring diagram with NC printed beside it. What does that mean?
I think they, isn't it?
Look, normally closed.
Thanks.
Normally closed. That means when it's at rest, it's closed. Got that? What does a dotted line between connectors indicate? Number 12. What did I tell you a few minutes ago? The connectors are the same one. I mean, all the wires, if you got a dotted line going across, connecting a bunch of terminals on a schematic like I drew a while ago, that means they're all going through the same connector. So if you unplug one connector, you're unplugging every one of those wires. Right? So number 13. Technician A says printed circuit boards may become etched if touched with bare hands.
Yeah.
Now, I'm going to tell you, most of the printed circuit boards are coated with plastic anyway, where even if you touch them, it won't hurt anything. You know what I'm saying? So, but Technician B says printed circuit boards are used to simplify the wiring of circuits. Okay, that's number 13. That's C. But basically, if you got naked copper and you touch it with your, hands with the acid that's in them, you can cause issues with that. But like on that little cluster we were looking at, that's all covered with plastic anyway. Even if you touch the printed circuit, you're not going to hurt it on that one. Number 14, we're going fast. Technician A says a common point is represented by a black dot on the wiring diagram. Technician B says a connector can be a common point. That's both of those guys are right. You've seen the black dot on the wiring diagram. It's like a splice, right? That's where the wire come together. What are you doing with your test? Are you doing anything at all? Okay. You already done it all? What? I noticed you weren't writing anything down. What's up with that?
I just wrote it down.
Okay. You're swift. Okay. Don't disconnect. Technician A says crimping solderless connections is the best method of splicing wires. Is it?
No.
That really stinks, doesn't it? Technician B says crimping should not be used if a connection is subjected to excessive movement or excessive current flow, right?
Well, see.
All right, so that's number 15 is going to be B, actually.
B.
Yeah. Technician A says a wiring diagram indicates where circuits receive their voltage source and the color of the wires used in the circuit. Remember, what I will tell you guys, I've said this before, power comes in from the top, ground comes in from the bottom. Now that's easy to remember, isn't it? Ground from the bottom, power from the top. You're going to get that. Technician A says wiring diagram indicates where circuits receive their voltage source and the color of the wires, and they will do that. You've seen that before. You got to recognize your legend, though. Blue on Japanese wiring schematics, L is blue. On German wiring schematics, SW is black, because the German word for black is Schwarz. Okay, Schwarz. Yeah, Schwarz. No, Schwarz. SWA.
Oh, man.
All right. All right, let's see. Number 16 is basically, look at that, it's going to be C. Now we got 4 questions left, and we're going to be diving into the shop. Technician A says wire harnesses pass from the passenger compartment of the engine compartment through bulkhead connectors. And typically they do. You know the great big connectors, the big round one that's got like 40 wires going through them? That's what they're talking about there. Technician B says a wire harness is a group of wires that branches out to various electrical components. Yeah, we know that. That's going to be C. 18. Ground straps are used to do what? A. Provide a return path to the battery between insulated components. B. Suppress electromagnetic induction, and that is going to be a C. Now, have you seen that some of these ground straps that are hooked from the engine to the body, they're just about always braided? Why would they do that? Why are they braided metal? The ground straps, it's naked braided metal. Sometimes they'll have each ring over it. Why do they do that? Anybody got any idea?
It's hot.
No, it's because 2 reasons. Because the engine moves on its mounts.
Yeah.
If you just put a plain piece of copper wire there, it's going to move on its mounts till it breaks the wire. Secondly, copper wires carry noise. So it'll carry noise into the engine, into the body of the car. And there was a motorhome. These motorhomes would come in there when we were working on. And when this is what would go on. You'd get in it and you'd take off, and as you got faster, the faster you went, the hotter the temperature gauge went. And then when you let off, it would go back. And the problem with those was they used a great big piece of battery cable about this long. It was a big double-aught, huge. And they'd have a little, a lug on each end connected from the engine block to the frame. But every time the engine block moved, whenever you would torque it, it would bend that wire a little bit, and finally it would break loose. So when you lost that ground connection between the engine and the frame, your gauges go crazy. Particularly the temperature gauge, one they notice. You'd go out driving through the parking lot, you'd get going 10 miles an hour, and that gauge would go on up. And then when you stop, it'd go all back down. Pretty crazy. It wasn't because the motors are weak. All right. 2 technicians are discussing shielded wire repair. Technician A says the shielded wire must be kept separate from the circuit wire. You don't want to have your circuit wire and your shield wire touching because the shield wire is grounded, right? Technician B says there's no difference between repairing a shielded or non-shielded wire. 19, that's A. And finally, number 20, and I know everybody's happy to see this one come. Technician A says a wiring diagram is an excellent tool in locating circuit failures. Technician B says most cases a wiring diagram is not necessary to locate all this. That guy's a yo-yo. Number 20 is A. That's an A. Okay.
Technically,